this is a prototype, okay, and I got the directions or the schematic for this from online, and you can get it, like I've got like a handout for you, and in the links at the back it shows you there's a link to a guy called Tony Messina, and he basically designed this circuit, and it's called a simple bat detector, and you can also make an enhanced bat detector, but if you actually do look online, there's loads of people trying to make them. Yeah, so that's the bat swarm at about 4 in the morning. So they're just going back into roost before the sun comes up, and they change into something else. Okay, so that's what a heterodyne bat detector, and it's a different detector because you actually have to tune in to different frequencies of different species of bats. Like some of them would echolocate at say 45 kilohertz, and then some of them would echolocate, well, it goes up to about 90 kilohertz. Now, I'll just line up some of the parts and tell you. Now, this is just a 9-volt battery clip, okay? So that's going to connect to the battery, which is our power source. And I just have some solder here, and these are called ICs, which are integrated circuits. And these two ICs are basically, they are for the gain or the amplitude. And this IC here is for the division of the frequency. So basically we have to divide an ultrasonic frequency down by 16 at least in order for the human ear to hear. A potentiometer basically has a little gauge on it that you can twist. So it's basically, this is the volume control. Basically that's it. Now this is the ultrasonic transducer. Now this is a capacitor. Basically a capacitor basically stores up energy and lets it out as the circuit, as the energy goes around the circuit. This is another capacitor as well, except this capacitor is polarized. This is also a capacitor as well, and this one is just going to connect the two ICs together. So this is just an earpiece. And I guess the last thing really is this is called a breadboard. If you want to test something out, basically you try it on breadboard first. The current on a breadboard runs this way, vertically up and down at the side, and this way. So these little ICs, okay, have numbers on them, okay, and this IC is basically, you can see there's a tiny little curve at the top of it. That's the top. That's how you know what an IC is and how the numbers, which direction they go in. So I'm going to put that there. There's our little half moon at the top, okay? You can barely see it, but all ICs will have it. This one has it as well, it's just there. But basically what it means is, from your left, it goes 1, 2, 3, 4, 5, 6, 7, 8, and these are your pins. So it's kind of bad to drop circuits as well, even though, you know, I mean, it doesn't seem like much, but they can be damaged pretty easily. So there's your 3 circuits. You know, you can spread your whole thing over that board because it's very small.
Okay.
Don't forget your half moon will be at the top.
Mm-hmm. I've got my half moon.
They come over easily.
Which are the half moons again?
The half moons the half moons will always be at the top.
Oh, right.
So
like
basically it indicates that that's the
top.
direction of the pins 1, 2, 3, 4,
right, yeah.
5, 6, 7, 8.
Right, so they're in, and then I need to put this in.
Yeah.
What do I do next?
Yeah, no, that's, you can, but I would suggest putting in your other capacitor first, okay? Now this is when I go back to my notes.
So this is the 50.
This is the, yeah, it's the 10
And
UF.
how do we know which one, which is it the polarized one?
The polarized one will go to pin 1.
The polarized one will go over there.
Pin 1 of your first IC. Any more, I'll cut some up.
It's ground positive and it's negative.
Okay, so
Ground
I
is
see
negative,
one.
Yeah.
really. It's just grounding it to nothing.
And it's always going to be
Two.
the black. Is it going to be the red line or the black line?
2,
It's going to be the black line is ground,
4
Yeah.
ground.
and you can
So
always use
2.
black wire.
And my ground is over.
You usually use green or black.
Yeah.
Okay.
So pin 7. All right, we'll just hang on a bit.
Yeah.
Okay.
Is this it?
Yeah.
Yeah, you're
Yeah.
going to have to
Oh, I'm
do
missing 2.
pin 2 and 4 for that one as well.
Yeah, sorry, it says IC 1 and 2.
Oh, 1 and... Oh, the same thing.
It's down here as well. pin 2. It's 470 capacitor. And just place it kind of where I had. I mean, I had my little
Oh, okay.
integrated circuit
So it's a
along
little
there.
bit above this.
Just make sure you know which side the negative is. It doesn't really matter.
I'm
if
going to
When
this
you
do
know,
the same
okay.
as that one.
Now, can I just ask a question? Could I put
One
that
thing
there?
about it is that you can't put it on your board. You can't put it like that.
Okay.
Okay, because your negative and your positive side are both on the same line. So you have to do it like that. Because the information is going this direction. The positive side or the negative side has to go to one of these lines, and the positive has to go to one of these lines. I want you to put the negative side to ground.
No.
Well, the next part goes from your positive is going from your positive pin on this. I can cut you some more if you like, Helena.
You don't need any more. So there should be one in here, right, for 14 for later.
You can do, yeah.
Connect this to this,
Yeah, go for it.
like that.
Yeah.
Oh.
Yeah, your other two, IC 1 and 2,
Yeah.
that row is going to go to pin 6 on both
Okay.
IC 1 and 2 as well.
14 to 6.
Well, it's going from do you remember that row?
Yeah,
above
this one
14?
above.
Yeah, yeah. It's going from there to 6. Number 2 is going to connect, this is the transducer. So one side of the transducer is going to go into, this is it here, IC1 on pin 3. And the negative side of the transducer is going to go to ground. But it's also going to be run off like a line, so it's going to go to 2, and it's also going to connect up with 6, or it's also going to connect to the other side of the potentiometer, and then it's quite complicated, this drawing. Like this actual potentiometer here is going to go to the tip of your, do you remember I showed you earlier, oops, that when this is your tip of your, and this is your ring.
Yeah.
And they basically carry different information. So when you put this in, it connects. That little thing there connects to ground, actually. It's nice.
Should I have to be an electrician?
Would I like to be? I don't know. Probably get paid better.
If I get a longer bit.
Do you want me to go
No,
for
I think this might be long enough. This has to go ground and 7. My positive
Yeah, that's your ground.
is to the ground, yeah?
No, your negative is to your ground. Sorry.
Oh, yeah, that's right
Yeah,
then.
that's right. There. It's really nice to get back into it, actually. It's really interesting because you start realising why the world is made up of all this stuff.
Yeah.
And it's just amazing. Like, and then you realise, like, you're looking at I was looking at all the broken stuff around the house, like, doorbells and phone lines, and you're kind of going, oh, now I know why that coil is there, and now I know why. But you're kind of going, oh, let's fix that. Or putting pin 2 of your IC3, I think, up to a different node or up to a different line. You could use black because it is actually going to go to a ground connection.
So 2 to...
And then you're going to put that line to ground as well. So we're going to just solder a black line out, see if it works. We're going to go from pin 2 down to about down to here.
Pin 2 of IC3?
Yeah. Put in the line of the last 2 of the potentiometer.
Oh yeah.
Can you hear that? So that should be working when you go outside.
Excited.
See, the idea basically, right, is to stick it in the little box and put a hole in here, and then basically hot glue it on. So you can put your mic through that,
So
right?
you have a little.
Yeah, you have a little portal out, and you can also then cover it up. But you can hot glue that down if you wanted to, if you didn't want to reuse the board.
And
Your
just have another
your
little hole
you put
then
your little
for
mic
your...
out there.